All right, so we know how to bond compounds now. So now all we have to identify is whether or not they are a molecule or a compound. Now, a molecule is a more general definition, and a compound is a more specific definition. So it's really not that complicated. All you got to do is if you're a molecule, you're formed when you have two or more atoms joined together. Okay, so as long as you got more than one atom in there, you're a molecule. So if you're a molecule and you have two hydrogen atoms, you have more than one, so you're a molecule. You have two chlorine atoms, so you're a molecule. You have two hydrogen atoms, and you have an oxygen. That's a total of three atoms. It's more than one, so you're a molecule. That's it. So basically, um, as long as you have more than one atom, you're a molecule. Now, if you're a compound, you're a little bit more, you're a more specific version of a molecule. So basically, everything that we bond, if you have to bond two elements, they're going to be a molecule. But not all of those are actually going to be compounds. If you're a compound, you can't just have more than one atom. You also, on top of that, have to have more than one element. So in the formula, if you see two different capital letters together, you're a compound. A way to think about it is when you have a compound word, okay, like doghouse or backyard, those are two different words put together. You don't say back or yard. You gotta have two different words to make a compound word. So like in chemistry, if you have two different elements like carbon and chlorine put together in some way, shape, or form, you're a compound. We have hydrogen and oxygen, you're a compound. You have hydrogen and chlorine, you're a compound. Carbon and oxygen, you're a compound. So all these guys are compounds. The thing is that if we look at our molecules, okay, if we said everything that we bond is a molecule, then why can't all of them be compounds too? If we look at the first two, we just have two hydrogen atoms. So that's not going to be a compound because we're bonding the same element twice. We don't have a different capital letter in there. The same for chlorine. We're bonding chlorine to itself. So that's the same letters twice. But here, for water, we have hydrogen and oxygen together. So that's a molecule and a compound. So if you are a compound, okay, by having more than one atom together, you're by nature also a molecule. But you're just a more specific version of a molecule where we call it a compound. So let's do a couple examples. So if we go to the key for what we did in class yesterday for bonding, we have our first one. We have two H's together, so that's the same element twice, so this is going to be a molecule because there's no different capital letters. There's no different elements in there. This one is going to be a molecule because we have two fluorines. Now, if we hop down later, we have CCl4. We have carbon and chlorine. So this is by nature a molecule because we're bonding something together. We have a total of five atoms here. But on top of that, we also have two different elements within the formula. So this is also a compound. So your task for today is to bond look over your bonds, make sure you did them correctly. But then also you want to identify, am I looking at a molecule or am I looking at a compound and a molecule? That's it.